Okay, welcome. So this is JobScout. Our mentors were Sohan and David, and the group was Nisim, Owen, Adir, Sam, and Ilan. There's our GitHub and the JobScout website, which we'll demo later on. So the problem that we are solving is that there are many websites for job searching, Indeed, Glassdoor, Monster, and it takes a lot of time for users to find every relevant job that they need, sorted by location or company or whatever they need, as well as to stay up to date on new job postings, because new jobs are being added all the time to these sites. Um, so the solution was a website that aggregates jobs from all these different websites into one database and then sends notifications with new job postings based on user job preferences. And you're also able to what's called do the notifications based on the user's preferences, like daily or monthly or whatever he needs. So the tools and frameworks we used were Python for backend code development, Streamlit for the UI, and FastAPI for the UI endpoints. AWS DynamoDB for storing the jobs and the tasks and the task scheduling. Boto3 for Python interacting with AWS. SQS for execution. EC2 for deployment. Flask for managing the Google logins, and SMTP for email notification.
Yeah, so in terms of the software design on the back end, the main two pieces was the job scraper, which would we used an API that would scrape jobs into a DynamoDB database. It would scrape jobs from all the different job sites, so that we could kind of create our own database of jobs from all the different places. The other main piece was the task scheduler, the distributed task scheduler, which served two main purposes. One was on the back end, it would refresh our database every whatever interval. Right now, it's set to every 6 hours. It resets our database. It refreshes our database with new jobs from the sites. And the other main usage of the task scheduler is that when a user on the front end, right, in the Streamlit page, they can do a one-time search or a save search. When they do a save search, it sends the search information to the task scheduler with whatever interval they want to be emailed, and then the scheduler every minute checks if there's any executable tasks, and then if there's any searches that need to be carried out, it will send a notification to the person via SMTP through the email that they use to log in.
And we had two working job scrapers. The first one, our primary job scraper, just scraped from LinkedIn. And the second job scraper we had is called JobSpy, which is able to scrape from LinkedIn, Indeed, ZipRecruiter, and Glassdoor. So that top screenshot you see has 50 jobs in it. That's when we ran the LinkedIn job scraper. And that bottom screenshot you see is after we ran the JobSpy job scraper, that added another 80 jobs. And that in terms of challenges we faced, the first one was deploying the JobSpy scraper. We ran into some issues when we tried calling it in the main script and just deploying it with the rest of the project. And the second challenge we faced was the need for third-party subscriptions. LinkedIn especially is very strict with who you're sharing data with. And it's very hard to scrape the job data that we needed. So you need to go through a third party and hit their APIs in order to get that data.
Yeah, so the way the distributed task scheduler works is that it really handles two types of tasks. There's notifications and refresh. Like we created an object called a task, which has two like subclasses, which are the notification and refresh. Every task has a task ID and a created timestamp and interval of execution. And then depending on the different types of tasks, it also adds other important information. So our task scheduler, every minute, it checks for executable tasks. And then if there's a task that needs to be executed, it executes the task by sending SQS messages. And we have two different SQS queues, which basically we had them constantly listening in the background so that to see if there's any messages sent. And if there was a search that needed to be executed, it would go to the notification queue. And if there was a refresh that needed to be executed, it would go to the refresh queue. And then those executions would occur. And the way this was all working on the back end was we were adding all the information to a tasks table and an executions table. The tasks table would store all of the tasks and all the relevant information that would be sent in the SQS messages at the right time. An executions table just for every task, it stored the next execution time, and each time it executed, it would update the next execution time based on the user's preferences for notification interval. So our code every minute would query the executions table to see what needs to be executed. And what makes this a distributed task scheduler is that we had multiple executor objects that could send messages to the SQS queues in order to execute the tasks that need to be executed, because in the event that there's multiple or hundreds or thousands of tasks that need to be executed every minute, it would be very slow if they all had to go through one executor. So when we boot up our system, we can kind of choose how many executors we want to be running in order to best deal with the traffic that we expect to face. And then and then all the tasks are distributed between amongst the executors so that it can all the work can be distributed and not all going to one place at the same time.
So as Adir said, we have two SQS listeners, one for the refresh and one for the notification. The refresh SQS listener, it gets the jobs to our database every interval, like every minute or so. And the notification listeners, it connects to the task table, and then the notification sender gets the email address from the user from the Google SSO login and connects to the notification listener to send their notifications with their preferences, like their time interval they want to get notifications from, which companies, and other things.
So when a user opens up our website, they're directed first to the logged out user page, and that's where they can execute searches, and they can enter a job title, location, company, and they only have the ability to do instant search results. But if they press login, they're directed to Google login page, and then from there they're directed to our Streamlit login page, which they can, in addition to doing searches, they can also save searches and see their search history. And Elon can speak more about how the login works.
So perfectly, thank you all. The way it works, we access the app, the initial app, which will display a login with Google button that you could see. In theory, it's really small, but in the top picture, the slide, I don't think you can read it. It's really small, but it says login with Google. So we press the button, and well, as Owen said before we log in, we can't save searches while we are logged out, and we won't receive notifications, etc. So we log in. We go to the Google's login page that we have all seen in different pages, in different parts. That's the second picture from up to down. And we log in with our email account. We need to have a Google account for that, a Gmail account. And we will see basically more or less the same app, but now it will display a logout button that if we press it, it will redirect you to the original app, and it will be like a cycle just like that. But and in this page, we have access to the we'll receive notification, we will save the searches, etc. And the way it works, so basically each account is unique because every account, as we know, has to be unique with its own information, and it has to store and associate the user with information we are storing about him, like the searches and stuff like that, and like the system has to know who's using the app right now. So once we redirect after the login, we are attaching the ID because every user has an ID and an email, so associated as a key value pair, basically. So we are attaching the ID to the URL for the website, making basically every single website for every user unique in a way, because the URL now has the ID for the person. It's part of the link, basically. So I think I said everything regarding this. And the skills we gained were, well, we learned more about using Git and GitHub. For example, we had to do branches and different issues and stuff like that. And well, that's what we learned regarding GitHub. We did stand-up meetings, and this goes associated with the working team. But in the stand-up meetings, we made sure everyone was doing okay. Like, it's part of what it means to work as a team, and working on a project as a team also has like, we needed to divide the different tasks and made sure everything worked along. And we these weren't different projects, it was one big project we had to connect, and that's also really important. And the communication part, I think, I mean, we can't left out that part. The communication between one another was really important, and something I think we all learned. We also learned to deploy a website, passing it from localhost to an actual URL. And we used AWS for different things. We used the IAM so we could all access as users in a way Owen's AWS account. So we were all working on the same thing, basically. We used EC2 as a terminal once we to run it once we deployed it. The SQS, we use it as a communication tool between the task scheduler and the execution services. And we use DynamoDB to store different things, for example, the ID and the email, the different searches, etc.
So what's next for this project? We still need to work on the load balancer to have multiple instances of our websites running. So if one fails, there's another so that the website is still on. We still need to deploy the new job scraper, which gets more jobs and a better description of the jobs. We need to improve the website and the email formatting so that when the notification is sent, it's well formatted and well described, not just words like in one paragraph. We still need to add some search suggestions so that you can search other things, not just one specific thing you have on your mind. We need to get more job scrape because I think we have our job scraper right now only gets up onto 200 jobs. And we need to have like a delete button for the searches that the users don't want, like after they search them.
All right, and we prepared a little demo for you. We'll play it for you now. All right, so here you see the jobs database. So after all the scrapers are run, this is where all the jobs go. And each job is assigned a job ID. You can see the company, description, link, location, and job title. And then once you get to the main page, we added this display all jobs for demo purposes because the newer job scraper still has to be integrated and deployed with the rest of the project. So these longer descriptions are from the newer job scraper. And the ones without long descriptions are from the primary job scraper that we've been using from LinkedIn. So if you go to the top, this is where users can actually search the database for jobs. So if you just try to do a search without entering any of the fields, you'll get an error message. If you just fill out job title, location, or company and try searching, you'll get another error message. And if you try to do a save search, then you'll see another error message. Logged out users can only do a one-time instant search. And here you'll see results, as well as the link to apply.
And here we can log in now to be able to save searches. So you sign in with Google account, Google SSO. And then if we come back to DynamoDB, the users table, we'll see the user information, right? The ID, the email, and the name. And then this logged in page has a lot of the same features as the logged out page. And that if you search without pulling anything out, it doesn't work. If you search that pick a notification setting, it also doesn't work. The one-time instant results work the same, but now you can actually save a search every minute or at any other interval that you want. I'm going to do a minute now just for testing purposes. Right, so that's just sending me an email within the minute. I can also, instead of searching by company, I can search by location or job title. But I can also search by all three. And if I go to DynamoDB, all of the searches will pop up in our tasks table. The zeroth task is always the backend refresh that starts with boot. So every 6 hours, our database is refreshed. You can see here that in type, this refresh the rest of these notifications, stores the user ID along with all the search preferences such as the title, location, the interval they want to be notified, the creation time, and the company. And then executions table actually stores the next execution time for all of the tasks. And then our task scheduler queries this table every minute to see if there's any executions that need to be executed every minute. Yeah, so then just to show back on the app, you can also display your searches. So everything pops up with all the important details of your search, like the title, location, company, and the interval that you want notified. And then you can log out to get back to the regular app. And now, just to show that it works, we'll go to Gmail. And we got our search results for CLA Health. And we should be getting the rest